All right, so today we're going to go over factoring quadratics, and I have our factoring flowchart pulled up here so we can use this to help us as we go through these examples. So we're going to start here at the very beginning where they ask us, is there a common factor? So for our example 1 over here, we have 12x squared minus 27. So when they ask if there's a common factor, I'm looking to see, does 12 and 27 both divide by the same thing? And in our case here, yes, they do. So because they do, then I need to factor out the greatest common factor. So to factor out my common factor, they have a 3 in common. So I will take a 3 out and then I'll write what's left. So if I take 12 divided by 3, that gives me a 4x squared. And then negative 27 divided by 3 gives me a negative 9. So if I go back to my factoring flowchart, it says, how many terms are there? So I'm looking at this example over here, and it says the 4x squared minus 9, that's the part that's in parentheses. I want to break that down more. And there's only 2 terms inside that set of parentheses. So since there's 2, I'm going to follow here. And it's going to ask us, is it a difference of 2 squares? So basically, I'm looking at the 4x squared, and I'm looking to see, is that a perfect square? So is 4 a perfect square? That means, is a number times itself going to be 4? And in this case, yes, it is. It's 2. And then is x squared a perfect square? Well, yes, because x times x gives us x squared. And then is 9 a perfect square? Yes, because 3 times 3 is 9. So when they ask us, is it a perfect square? Yes. Oops. Yes, it is. So I just have to factor into this a minus b, a plus b. So in my problem over here, I have this 3 on the outside of the parentheses. It's going to stay there. And so to factor this, I have to break this down. So remember, we said 4 was 2 times 2. So I'll have a 2 in both parentheses. X squared was x times x, so I'll put an x in both parentheses. And then 9 was 3 times 3, so I'll put a 3 in both parentheses. And then one of them has to be a minus and one of them has to be a plus, because that is the only way I can multiply 2 numbers together to have it equal a negative number, is if one of them is positive and one of them is negative. So if I go back to my factoring flowchart, it says we're almost done. Check to see if any of the expressions in the parentheses can be factored more. So if I go back to my problem, I look at this 2x minus 3. That is broke down as far as it can get. And then I look at the 2x plus 3, and that is also broken down as far as it'll go. So nope, can't be factored more. So since it's not, it says we're done. So my answer would just be this 3 times 2x minus 3 times 2x plus 3. All right, so for our second example, we will start over on our flowchart. So start up here, is there a common factor? So if I look at 6, 13, and 5, I'm looking to see, do they have something in common? In our case here, no, they don't. So no, there's no common factor. So then they ask us, how many terms are there? And in our case here, we have 3 terms. So if there's 3 terms, we have to use the diamond grouping method. So my diamond grouping method, I'll put my diamond over here. So I have to take my a times c. So I'll take 6 times negative 5, which is negative 30. Goes in the top part of the diamond, and then my b term, that middle term, that number that's with just x, goes in the bottom part of the diamond. So that would be negative 13. And now we're looking for 2 numbers that multiply to be negative 30, but add to be negative 13. Now, since it's a negative 30, that means one of the numbers has to be positive and one of the numbers has to be negative. So I know most people usually go, hey, 10 times 3, that would be perfect, except since one of them has to be negative, that means I'm going to be subtracting these numbers. And so if I take negative 10 plus 3, that gives me a negative 7. So that does not work in this case. I'm going to have to use other factors of 30. So looking at this, I'm thinking, let's try negative 15 and 2. So if I take negative 15 times 2, that gives me negative 30, and negative 15 plus 2 will equal a negative 13. So that is the pair that I need. So I'll have negative 15 and positive 2. So once I have my factors from my diamond, this is where I go do the grouping part. So I have this 6x squared is going to stay here. This negative 13x, that's what I get when I combine the negative 15 and the 2. So what I'm going to do is I'm going to split this back up and make it a negative 15x plus 2x. And then I have my minus 5 at the end. So if I would combine my like terms, I would get the problem that I started with, this 6x squared minus 13x minus 5. Remember, when we factor, that means we're unfoiling. We're trying to undo the distributing, the multiplying out. So now I'm going to group the first two terms together and group the last two terms together. So looking at just the first two terms, I want to factor out what they have in common. And in our case here, they have a 3x in common. So I'll take out a 3x. And when I do that, 6x squared divided by 3x gives me 2x. And then negative 15x divided by 3x gives me a negative 5. And then I look at the last two terms. So I look at the 2x minus 5. The only thing that they have in common really is just a 1. So I'm just going to factor out a 1, take a 1 out. And then we would be left with 2x minus 5. So now if I did this right, the part that's in parentheses should be the same on both problems. And they are, so I can factor that out since they have that in common. So I'll have a 2x minus 5 times 3x plus 1. So now that I've finished factoring that, it says you're almost done. Check to see if the expressions in the parentheses can be factored more. So I look at this, I have a 2x minus 5, that does not break down more. And then I have a 3x plus 1, and that does not break down more. So that means we are done. All right, so if I go to example 3, back to my factoring flowchart, I'm starting back up here at the top. Is there a common factor? So I'm looking at 2, 14, and 36. Yes, there is a common factor. They're all even, so I know I can take out a 2. So if I take out a 2, I'm left with x squared minus 7x minus 18. So I divided all of those numbers by 2. And now they ask me, so I factored out the GCF. How many terms are there? So in the parentheses, I'm left with 3 terms. That means I'm using my diamond method to factor again. So I will come back here to my diamond. This time my a, the number in front of the x squared, is just 1. So I'm taking 1 times negative 18. So I get negative 18. And then my b term is negative 7. So I'm looking for 2 numbers that multiply to be negative 18, but add to be negative 7. And the ones I come up with are 2 and negative 9. Because 2 times negative 9 is negative 18, and 2 plus negative 9 is negative 7. So now if I go do the grouping thing, so I'll have x squared plus 2x minus 9x minus 18. So if I group these first two together, they would have an x in common. So I'll take out an x, and I'm left with x plus 2. And then if I group the last two together, they have a negative 9 in common. So I'll take out a negative 9, and I'll be left with x plus 2. And now if I do this right, the parts in parentheses should be the same. So I have this x plus 2 times x minus 9. And don't forget, we had this 2 that was on the outside. So my answer would be 2 times x plus 2 times x minus 9. So now if I come back here, it says we're almost done. Check to see if any of the expressions in the parentheses can be factored more. So x plus 2 is broken down as far as it can go, and x minus 9 is broken down as far as it can go. So we are done. All right, so now if I go back up to the top and start over again. For my fourth example here, they ask us, is there a common factor? So looking at 6, 3, 96, and 48, I'm looking to see if they have anything in common. And in our case here, yes, they do. They are divisible by 3. So if I take out a 3, I'm left with a 2x cubed plus x squared. And then negative 96 divided by 3 would be a negative 32x. And negative 48 divided by 3 would be a negative 16. So now I go back. So yes, factor out my GCF. I did that. How many terms are there? There are 4 terms. So I come down here and it says factor by grouping. Don't forget that you can also rearrange the terms and then group. Well, I'm not going to rearrange my terms. I'm going to leave them just as they are because they're written in order. So if I group, that's what we've been doing here. We just group the first 2, group the last 2. So if I look at the first 2, they have an x squared in common. So I'll take out an x squared, and then I'm left with 2x plus 1. And then out of the last 2, 32 and 16 are both divisible by 16. And since they're both negative, they would have a negative 16 in common. So I'll take out negative 16, and I'll be left with 2x plus 1. Now, if I do this right, the part in parentheses should be the same, and it is. So I will have 2x plus 1, and then an x squared minus 16. And then don't forget we had that 3 on the outside, so I'll put the 3 there. Now it says we're almost done. Check to see if any of the expressions in the parentheses can be factored more. So looking at this, my 2x plus 1, that's broken down as far as I can get. The x squared minus 16, oh, I think that one I might be able to factor more. So if I go back up to the top, I'll do this. So is there a GCF? No, they don't have anything in common. How many terms are there? There's 2. So is it a difference of squares? So is x squared a perfect square? Yes. And is 16 a perfect square? Yes. So this means I can factor that into this a minus b, a plus b stuff. So I'll have 3, and the 2x plus 1 stays out front, but the x squared minus 16 will break down into x minus 4 and x plus 4. And that would be, let's see here, we're almost done. Now I got to check my parentheses, make sure that they don't break down more. We already said 2x plus 1 was fine. X minus 4 doesn't break down, and x plus 4 doesn't break down. So this would be my final answer.